Today you're watching a video on scientific notation. I strongly suggest you document these notes in your notebook. Let's begin. Scientific notation is nothing more than a way to take numbers that are really big and numbers that are really small and put them in a standard form, if you will, that everybody can understand. So, first, let's just define scientific notation. Scientific notation is a number written in the form C times 10 to the nth power, where 1 is less than C, which is less than 10, and n is an integer. Well, that's a lot of words. That's just a lot. So, as usual, in class, we break it down. We're going to do the same thing. Scientific notation is the form C times 10 to the n power. C is this type of example, 2.8. And C is always less than 10 or greater than 1. And we'll look at more of it. N is your exponent. Your exponent is always an integer. Also, the exponent tells you how many places to move the decimal and which direction to move it. So, for example, here in 2.8 times 10 to the 8th power, 2.8 is a number that is greater than 1, less than 10, and it's always multiplied by the base of 10, and the exponent is positive 8, which lets me know we are moving to the right 8 spaces because it's positive. Before we look at examples, let's look at a couple more things. Numbers can be written in 3 ways. Standard form, which is regular numbers 1, 325,000.0005. Product form is this example, which we really don't use quite frequent. But we will begin using scientific notation. And again, it's a way to take really small numbers like the size of a cell. We know cells in our body are really small. Or we could look at numbers like the distance from Earth to space. We know that's a far away place, and so that number will be very large. Scientific notation is used to represent those numbers. So, how do you write numbers in scientific notation? Couple of things you need to remember. Your exponents let you know which direction to move things, your decimal to be specific. The exponent tells you how many spaces to move the decimal. If the exponent is negative, think about an integer line. Negative to the right, to the left, positive to the right. Exponent's negative, you're moving to the left. Exponent positive, you're moving to the right. Let's look at some examples. Example 1. A molecule has a diameter of about 0.000000004 centimeters. And it wants us to write in scientific notation. The first thing you do is look at your first number that is not 0. That is C. You always multiply it by a base of 10. And we're trying to now figure out the decimal. Well, I can already look and see 4 is to the right of my decimal, which means if I'm moving towards the decimal, I'm going to the left, so it's negative. How many spaces am I moving to the left? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 spaces, so my final answer is 4 times 10 to the negative 9 power. Let's look at another example. A cubic meter of aluminum has a mass of 2,700 kilograms. Write in scientific notation. Well, I noticed this one's a little different than the last one because I don't see a decimal. But I do see my first two numbers that are non-zero. I could think that this is my first base, but what is wrong with 0.27? It is not greater than 1, and that is the rule. I could also write and think about 27 as my first base, but then I look at that and I know that is not less than 10. So I look at my first two non-zero numbers and put the decimal in between. 2.7 is greater than 1 and less than 10. And I know, again, my base is always times 10 to the what power? Well, I don't see a decimal, but I know I put my decimal in between 2 and 7, and I'm moving to the right. 1, 2, 3. And because I moved to the right integer line, it's positive. Take a moment and try these two examples on your own to see if you can just get what I just said in your notes. I'm going to continue so you can pause it here, pause the video, and check your work. Example number 3, 4,000 in scientific notation. I only see a 4, so I know that's my base, the first one, times 10, no decimal, moving to the right, 3 spaces. Oh my goodness, this next example is really, really big, and this is a prime example of why scientific notation was created. My first two numbers, non-zero, are 63. I can't have 0.63. That's not greater than 1. And I can't have 63. That's not less than 10. So I'm going to put the decimal in between the 6 and the 3. Base 10, moving 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 6.3 times 10 to the 10th power. What about these two? Again, pause the video and try on your own. I'm going to continue. Here I see a decimal, so I already kind of think that my exponent will be negative, but let's just see. My 3 numbers, doesn't matter how many it is, the numbers that are non-zero. 4.75, can't have 0.475, that's not greater than 1. Can't have 475 because that's definitely not less than 10. 4.75 works for both of those rules, times 10 to the, putting my decimal in between my numbers 4 and 7, and I move to my next decimal to the left, 1, 2, 3 to the negative 3 power. Same thing for this last example here. Oops, let's move that down. First two numbers, non-zero, 8.2. I already know, greater than 1, less than 10. And I'm moving 1, 2, 3, 4, 5, 6, 7, 8, 9. To the left, negative 9. I hope you understand what we just did to get our standard numbers into scientific notation. So now let's continue. Excuse me, going the wrong way. And taking scientific notation and writing numbers in standard form. Same concepts, the exponent that is with your base 10, and we called it n, tells you which direction to move numbers. If it's negative, we're making that number smaller because we're moving to the left of the integer line. It's becoming smaller. On the integer line, if the exponent's positive, we're moving to the right, making it bigger. The exponent tells us everything. So let's look at an example. Write in standard form 4.1 times 10 to the 5th power. So I'm going to take the first numbers given and write them down, not including the decimal. And I'm looking at my exponent and it's positive 5. Which direction should I move? Right. Starting where the decimal was in the original problem, I'm moving to the right. 1, 2, 3, 4, 5. Oh my goodness, what should I fill those humps in with? You guessed it, zeros. And now I have a number 410,000 written in standard form. Let's take another example. 2.15 times 10 to the negative 3 power. Again, taking my first number and just writing it down. not including the decimal. The decimal's there, but it helps me know which direction to move along with the exponent, which is -3. So which direction am I moving, guys? Yes, to the left. 1, 2, 3, and I want to include the decimal, and I'm filling in with 0. So my new number is 0.00215. We can check our work by 1, 2, 3. Oh, 3. That's the exponent I wanted. It's to the left of the first whole number that is not 0. We've done it correctly. We're going to stop here. You will not need to complete this exit ticket. You have directions to move forward with continuing to practice scientific notation. I hope you enjoyed the video. Again, make sure you've gotten this information in your notes.